So tonight we are talking about Swift optional, which is, I guess it's one of the fundamental things in Swift when you are sort of maybe coming from another language. It looks a bit weird and it takes a little bit of getting used to. Now this talk is going to be, it's an intro, so we're just going to be talking about how you use it and not, how it works under the covers or anything like that. So hopefully it makes sense to everyone. And Swift optional is really about how we handle these bad boys. So they all more or less mean the same thing, but we've got, in Swift we call, and ObjC we call it nil. And I think Ruby's the only other one that does nil. And then most languages call it null, or some languages call it zero. It's somebody on a bike. Somebody's fallen off a bike. Yeah. All right, so in lesser languages, and is anyone here a Java programmer? Kevin? So we might have something like this. I've just completely made up some code here, but there's some intentional bugs here. Kevin can tell us what it is. What's going to happen here? User could be null, yeah. And what happens in Java, if you call something like get full name on user, if user's null, you get a null pointer exception and probably your program's going to crash. And so what we end up having to do in languages like Java, where anytime we try and use anything, we have to check to see whether or not it's null first, and then we can actually call methods on it. So that's a lot of fun and hilarity. The painful thing about this, the thing that always annoyed me about it was knowing when something might be null is mostly based on experience and wisdom and things like that. If you're using ReSharper, maybe, not ReSharper, any of the IntelliJ products, they'll give you a red squiggly line and say, hey, this might be null, you maybe should put a null check. But other than that, it's pretty much looking at some code and just knowing through long and bitter experience that it might crash there is the way that works. You'll notice also we need to check that user's null and then full name's not null and then first name's not null because any of those might be null and then we'd get a crash down here as well. I'll also add integer.toString conceivably might return null. I'd have to look at the documentation to check whether or not that can happen, most likely. So luckily I just know that it won't return null, and so that's all good. The only other thing I wanted to point out here was we've got this value here that's coming in, our number of pineapples. That's a value type in Java, and that can't be null. So that's always got a value, which that's good, right? But sometimes we might want to know whether it doesn't have a value. So if we don't know how many pineapples somebody's got, you can't pass through 0 because they might have some. So. Often we end up coming up with a magic number and then declaring a constant and then using that magic number everywhere where we're trying to represent the fact that there's no value there. So that ends up getting a little bit awkward. So yes, this is how it's done in Java. We don't like that. When Apple went and started developing Swift, they obviously wanted to get away from this because it's not very user-friendly. Especially people who are new to the language, it's hard to pick this sort of stuff up because, again, it's just things that you have to know.
You have to say the language that dealt with this extremely elegantly for years.
Yes. Tim's going to tell us all about that later. All right, so how does Swift solve this one? So Swift solves this one with some magic. Basically, everywhere something might be nil, you put a little question mark after the type name. Okay, so int can't be nil, number can't be nil, oops, number might be nil. All right, so question mark, no question mark, and that'll basically say, yes, number's always going to have a value, or no, number might have a value, or it might be nil. All right, and so the way that this looks like in code is if we've declared something up here as an optional, so we've got our numbers being declared as an optional, basically Swift is going to fail to compile, so it's going to give us compiler errors when we try and use it if we're not testing to see if it's null or if we're not unwrapping it in some other way. So that's really handy. The other thing is Swift allows you, which most traditional object-oriented languages don't, Swift allows you to declare a reference type as not optional. So the reference type will always have a value, whereas in languages like Java, reference types can always possibly be null. So I'm not going to talk too much more about reference types versus value types. That's probably a good option for another talk. But the nice thing about Swift's approach is it's the same process for both. It doesn't matter whether it's reference type or value type. It's the same notation and the same usage. Okay, might be nil, might not be nil. All right, so how do we use optionals? So we can do, if we were looking at this line here, where it's going to throw a compiler error, if we try and call that, the way we can get Swift to stop throwing compiler errors is we can put a little question mark here after number before we call our method. What that's going to do is if number is nil, it's just going to return nil. Okay, if number's not nil, it's going to call this method on it and return the value. Okay, and we will end up with an optional as the return value. And we can chain together multiple of these. So this is really, really handy if you've got methods that might themselves return optionals, because they'll all just get flattened into, it'll end up with a value or it'll end up with nil. This isn't a very good example because they don't return optionals, but if they did, that's how it would work. And then one of the operators that's commonly used in conjunction with that is what's called the nil coalescing, the double question mark here. Okay, and that is basically if this returns a value, that's the value. If it returns nil, default to this one. Okay, and that's really, really common to use in conjunction with the optional chaining. And I might add, it's really good to do this for booleans because optional booleans are a pain to work with. Generally with a boolean, you're dealing with true or false. You want to put it in an if-else statement, but if it's optional, you've got true, false, or nil, and it's not as obvious what nil means in that case. So it is a good idea to come up with a default value when you are using. So that's the little tip, the little teaching point for this one is try and avoid or get rid of or default optional booleans as soon as you can. All right, so let's say we can't do chaining. We actually want to pass, we need to pass a value through to a method or something where it requires a non-optional value. So we can get at that using a force unwrap. So in this case, we're wanting to use mathematical operators. Okay, so what we can do is force unwrap. This is the question, the exclamation mark. Force unwrap gets the value out of the optional, and then you can use that as a non-optional value. Now the downside of this obviously is if it is nil and you force unwrap, your program's going to crash. Okay, so that's the main reason why generally it's bad style in Swift to use force unwraps in a lot of places. So there are better ways to do it. So one thing we could do is do similar to what we did with the Java code. We can test to see if it's nil first, and then we can unwrap it. Okay, and I say shouldn't crash. Okay, if we do have, so this should be safe, but if we had, for instance, a reference type, if we had user.firstname, and we check to see that it's not nil, and then we try do something with it, you might have scenarios where user.firstname is not nil when you check it, but then by the time you try and unwrap it, it's been set to nil on a different thread, and it crashes, and you can't troubleshoot those. They're a pain. So this pattern itself, we try and avoid that as well. So luckily, Swift gives us the ability to do this, and this is what's using the if-let statement. So rather than if we do if-let and make an assignment here, we can basically test to see whether the number's nil. If it is nil, then we just skip the whole let block and go on to the next, to the next section of code. If it's not nil, then we assign it to our non-optional number variable here, and then we can do stuff with the non-optional. And this is the safer way of doing it, and this is what you should be doing if you do need to get to a value, get a non-optional value out of an optional. All right. It's also fairly common to shadow the identifier here, so we can use, this is valid code even though it looks a little bit odd when you first look at it. What we're doing is we're creating a new variable called number, which is non-optional, and we're populating it with the value out of the optional value number. They're both still there, but you can only access the non-optional version. So this is generally frowned upon, shadowing in other scenarios because it can get really confusing. But it's fairly common with optionals because you can do things like do a guardlet at the top of a method, check to see whether a parameter is nil or not, and then do an early return, and then for the rest of the method you've got a non-optional. All right. The other thing with let bindings, you can chain together multiple assignments. So this is good if you need to pass a non-optional through to a parameter. Rather than nesting if-lets, you can just do them in the one if statement, and at the end of it, we're doing something with yet another. I could have probably come up with a better example there, but that's what you're getting. All right, so implicitly unwrapped optional is probably the last sort of component of the language I'm going to go through here. Instead of declaring a type with a question mark after it, we can declare it with an exclamation mark after it. Okay, so the bang, as they call it. What this means is that it is actually an optional, but we don't need to unwrap it or if-let or do whatever when we use it. Okay, it behaves like it's a non-optional. The downside there is it's kind of like the compiler's going through and doing a force unwrap every time we access it. So we might end up with a crash there. Okay, so if it sounds like implicitly unwrapped optionals are a terrible idea, it's because they are. You shouldn't use them pretty much in any case except for outlets or any scenario where you have delayed initialization. So because Swift requires you to set properties in the class initializer, if you don't have them at that stage, but you do guarantee you had them at a slightly later stage, then that's where you would use implicitly unwrapped optionals. So in the case of like view controllers, iOS is going to guarantee that you've actually got values set by the time view did load is called. Of course, if you forget to do your connections, then it's going to crash, but that's probably what you want. Probably.
Well, you used to be able to do that comparing with ObjC.
Yeah, it does not respond to selector. Yeah. All right, so here's my tips. So don't use bangs, okay, that's exclamation marks, force unwrap. Use if-let or nil coalescing to get at non-optionals. What I do sometimes when I'm doing a code review on Swift code is I just do a search for an exclamation mark and see what turns up. It's a really, really good, even on my own code, it keeps you honest. Use guardlet at the start of methods for early exit. I don't think I actually put an example of guardlet in there anywhere, but guardlet is enables you to check to see whether or not something's nil, and if not, it'll if it is nil, it can return early or throw an error or whatever makes sense. Use chaining and multiple bindings in one if-let to remove all your optionals. So that's to avoid nesting if-lets, which we want to avoid nesting if we can. Extract code into a method so you don't need to use an if-let. I like using this one a lot. If you do need a non-optional, rather than, particularly in callbacks, rather than going, particularly in callbacks where you're weakly capturing self, it's really nice to be able to just call a method on self using option chaining syntax rather than doing it if-let self equals self, etc., and then passing self through to an alert controller or something. And don't use implicitly unwrapped optionals in general except for outlets. So if we reviewed our Java code, that's just a reminder of what it looks like. What we might want to do in Swift would be something like this. So we can pass through nil as our number of pineapples if we don't know how many pineapples we've got, but we know that person's always going to have a value because it's non-optional. It's not marked with a question mark. We can do a guardlet to make sure that we can get a non-optional version of number, and then we can use string interpolation, which is much nicer than what Java was doing. So use Swift. All right.